Good morning, friends. Once again, a warm welcome for a new day and for online learning in chemistry. Today, we will just summarize what we have studied up till now. We have started the chapter 2, that is analytical chemistry, that is study of analytical chemistry. And in this chapter, we have studied different concepts, just like empirical formula, molecular formula, then problems of empirical formula and molecular formula. We have studied solving empirical formula and molecular formula by two methods. One it is a stepwise method and the other is a tabular method. Also, then we have gone to the next topic, that is stoichiometry. What do you mean by stoichiometry? And also problems on stoichiometry. And today we are going to come to a new concept with regard to mole concept, regarding different mole concepts in chemistry, especially used in analytical chemistry. So let us study what are those mole concepts. My dear children, before I go to the slides, I would request that you please note down whatever we are going to see in the PowerPoint presentation, and at the same time, I want you to go to each and every topic in detail, keeping your textbook in front of you and start studying. Yeah, if you see here, last time we have stopped here, we have calculated the amount of calcium carbonate decomposes. So we have calculated about 2.8 grams of calcium carbonate, which is required, which is calculated for 5 grams of calcium carbonate will be produced. So this we have studied last year, yesterday, and today we are going to start with some important concept, that is concentration of solution. Now, what do you mean by concentration of a solution? To tell you in a very simple language, we have got different types of solution. One is a dilute solution, one is a concentrated solution. And in a simple language, we would say, when I want to prepare a sugar slurry, commonly when we say, we use this sugar slurry for when we are preparing gulab jamuns. And that time we use in Marathi आपण म्हणतो साखरेचा पाक. आणि या साखरेचा पाक आपण कसा तयार करतो ते आपल्या मम्मीला नक्कीच माहित आहे घरामध्ये. And when we say this concentrated solution, we are dissolving maximum amount of solute, that is a sugar, in minimum amount of water, that is a solution. So we are dissolving maximum amount of solute in minimum amount of solution. So solution here is water and the solute is sugar. Similarly, when we prepare different types of solutions in chemistry, we try to prepare a concentrated solution, a saturated solution. So concentrated solution means it is a strong solution. Saturated solution means maximum amount of solute in minimum amount of solvent. So that is the way it is. So majority of the reaction in the laboratory are carried out in this concentrated solution, concentration of solution. Maybe a dilute solution or a concentrated, a stronger solution or a dilute solution. Therefore, it is very important to understand how the amount of substance is expressed when it is present in the form of a solution. Now, what is a solution? When we say solution, solution of, say, I will say sugar and salt. Sugar and salt. So what is sugar? Sugar is a solute. What is salt? Salt is also a solute. So when we dissolve sugar and salt in water, so water becomes the solvent. The water becomes a solvent. So we are trying to dissolve solute in a solvent. So that is a solution. So the concentration of solution or the amount of the substance present in a given volume of a solution can be expressed in any of the following ways. In any of the following ways. The first is mass percent or the weight percent. So we take mass, till yesterday we have mass, atomic mass and on so on. Weight and mass is one of the things. So mass percentage or weight percentage is one of the same. Mass, we also say mass nowadays, we say, for weight we say mass, and old term is weight. So weight is amount, how much? So weight percent. The second is mole fraction, The third is molarity, and the fourth is molality. So this is a new term which is there. So let us see what is mass percentage. So it is obtained by using following relation, that is mass percentage is equal to mass of the solute upon mass of the solution. So solute, if I say 1 kg of salt, so mass of the solute is 1 kilogram, and mass of the solution is, I'll say 1 liter of the solution. So the unit of solute is grams or a kilogram, and the unit of solution, when we say unit of solution in measure is liters. So mass of the solute divided by mass of the solution into 100%, because we are calculating for percent. So this is how we can calculate the mass percentage of a particular compound. A solution is prepared by adding, this is a problem. Question is, a solution is prepared by adding 2 grams of substance A could be any substance A or X, to 18 grams of water. So the amount of the solute is 2 grams, and the amount of water they have calculated, converted into grams, that is 18 grams of water. Since we are calculating, whenever we are trying to solve a problem, we try to bring all the units in one particular configuration, maybe MK system or CGS system, whatever it is. So we are trying to bring all the units. So here it is 18 grams of water. So calculate the mass percentage of the solute. So you have to calculate the mass percentage of the solute. Here grams of water. So water is a solution. So a solute is there, that is 2 grams substance of A. So here solution is equal to mass percentage of A equal to mass of A. How much mass of A is 2 grams. Divided by mass of the solution. How much is mass of the solution? 2 grams of A, that is 18. That is 18 grams of water, right? So 2 grams of A plus 18 grams of water. That is mass of a solution. So why? Because this solution is made up of 2 grams of A plus 18 grams of water, right? So 2 grams of A is the mass of the substance A. Divided by mass of the solution. Solution is made up of what? Solution is made up of a solute and a solvent. So this is the solution. So solution is 2 grams of A plus 18 grams of water. So that becomes 20. So 2 grams divided by 20 into 100, that is 10%. So this is the 10%. 2 divided by 20, that is 10. 10 into 100, that is 10%. So the percentage is, that is the mole, that is mass percentage of the given compound A is 10%. So this is a way to solve the problem on mass percentage. The next part of this is mole fraction. Now what is mole? Mole fraction. It is the ratio of number of moles of a particular components of a solution to total number of moles of a solution. So what is a mole? It is a ratio of number of moles of a particular component of a solution to the total number of moles of the solution. So if a substance A or X dissolved in substance B and their number of moles are n number of A and number of B. So number of A and number of B respectively. Then the mole fraction of A and B are given as. This is a formula, very simple. Mole fraction is equal of A is equal to number of moles of A divided by number of moles of the solution. So number of moles of A upon number of moles of that solution. Therefore, mole fraction of A is equal to number of moles of A divided by number of moles of A again plus number of moles of B, because the solution is made up of A and B. Therefore, mole fraction of B is number of moles of B divided by number of moles of the solution. And that's why the relation mole fraction is number of moles of B divided by number of moles of A plus number of moles of B. So this is how the mole fraction has been calculated. So simple words, there are not much problem, but you should know this derivation very well. The third is molarity. Molarity, we will come across during the practicals very oftenly when we are doing volumetric analysis, we'll come across this term molarity. It is the most widely used unit and it is denoted by capital M, molarity. Molarity, molar, molarity. It is defined as the number of moles of the solution of the solute present in 1 liter of the solution. Now here the unit of volume is liter. So here what is molarity? It is, first of all, it is very widely used unit and it is denoted by the capital M. So the denotation of molarity is capital M. It is defined as the number of moles of the solute present in 1 liter of the solution. So what is solute? If I say 1 kilograms of salt, maybe any salt, calcium carbonate salt, copper sulfate salt, and so on, sodium chloride salt, any salt. So if I dissolve one, that is a solute, say 1 kilograms of a salt. So it is defined as number of moles of the solute present in 1 liter of the solution. So if I dissolve, say 1 kilogram of salt in 1 liter of the solution, so that will give you 1 molar of the solution. So solution, when I prepare a solution, I use, now here solution when I say, it has got 1 liter of the salt plus 1 liter of the water. So that is solution. So my dear friends, do not get confused with the words. Solute means a solid form. It is in a dry form. Say calcium carbonate. In simple words, I will say common salt. That is a solute. Water is a solvent. So it is water, just a plain water. It does not have anything except it is composition, that is hydrogen H2O. That's all. Okay, it's a clear transparent solution, that is a water. And a solution means when I add this salt to this water, that is a solvent. So I am adding a solute, that is salt, to this solvent, that is water, I get a solution. When I stir well, I get a solution. So that I will say a salt solution. Thus, how is the molarity? Molarity is denoted by capital what? Capital M. So, molarity is equal to number of moles of solute. Number of moles of solute. Solute means the salt upon volume of solution in liters. Solution means solute plus solvent. That is solution. So here, volume of solution in liters. When I say solution means solute plus solvent. So this is the formula for molarity. If you see here, we can calculate, there are some problems on molarity. So here the problem says, calculate the molarity of NaOH in the solution prepared by dissolving 4 grams in enough water to form 250 ml of the solution. So here the solution is, you have to prepare, you have to calculate, the solution is NaOH. NaOH in the solution prepared by dissolving 4 grams in enough water to form 250 ml of the solution. So I have to prepare 250 ml of the solution. I am using 4 grams of NaOH. and I'm using enough water to form 250 ml of solution. And here the solute is NaOH, the solvent is water, and I have to prepare a solution. Now here, molarity. Since molarity is equal to number of moles of solute, the number of moles of solute, that is the solid, that is NaOH, upon volume of solution in liters. So that is how we can see. So volume of solution in liters. Now here, molarity is equal to mass of NaOH. What is mass of NaOH? 4 grams. Upon molar mass of NaOH. Molar mass of NaOH. That is, what is molar mass? 40 grams. Upon volume of the solution in liters. What is the volume of solution in liters? When I am saying in liters, this is in 250 ml. So 250 ml I will convert into liter, that is 0.250. That is 250 ml, right? Liters. So 4 grams is mass of NaOH. 40 grams is molar mass of NaOH divided by 0.250 liter. So that is pow liter. In a common language, pow liter. Right? So molar, therefore molar M is equal to 0.1. Why? How you got 0.1? 4 divided by 40 is 0.1 mole. Upon 0.250 liter of the solution. Now here, therefore molar is equal to, that is 0. So on division of 0.1 upon 0.250, I get 0.4 molar L raised to minus 1, that is equal to 0.1 m molar of the given. So molarity of this solution is 0.4 molar. Here, note that the molarity of the solution depends upon the temperature, because the volume of the solution is the temperature dependent. So volume is always on the temperature dependent, and that's why it is depends upon the temperature. How is the solution? The temperature of the solution. So this is the problem on molarity of the solution. Next, fourth one, we go to, it is not molarity, but it is molality. Molality. How it is defined as molality? Molality is defined as the number of moles of solute. Number of moles of a solute present in 1 kg of the solvent. And it is denoted by small m. Now I will go to the back slide. First of all, what is this? What is molarity? It is in 1 liter of the solution. It is also solute present in 1 liter of the solution. What is molarity? It is also solute present in 1 kg of the solvent. So in molarity, how will I distinguish between molarity? It is liter, 1 liter. Solute is dissolved in 1 liter, present in 1 liter. But in molality, it is 1 kilograms of solvent. So it is also a number of moles of a solute present in 1 kilograms of a solvent. Here in molarity, it is denoted by capital M. But in molality, it is denoted by small m. It is denoted by small m. So it is denoted by small m. So that is the more major difference. But above all, what is the major difference? One is solute present in 1 liter, that is molarity. It is denoted by capital M. Molality, it is solute present in 1 kilogram of solvent. 1 kilogram of a solvent, and it is denoted by small m. So here molarity is number of moles of a solute divided by mass of the solvent in kilograms. That was in liter. Here, that molarity of a solution does not change with the temperature, where that was temperature dependent. Since mass remains unaffected with the temperature. There it was temperature. If the temperature was there, it would change. Here, does not change. Often in chemistry laboratory, a solution of a desired concentration is prepared by diluting a solution of a known higher concentration. Most of the time when we get concentrated, we get acids, all acids to that extent. Which is in a ready-made form. When it comes in a concentrated form. Then we dilute it as per our concentration, whether we want 1 molar, whether we want 0.1 molar, 0.2 molar, 0.5 molar, and so on. So depending on that, on the basis of the calculation, we try to concentrate with water. We try to dilute the concentration. So we try to add water and make the solutions as a dilute form, or maybe desired concentration form, whatever concentration we want. So that concentration, by adding water to the concentrated solution, suppose I want to prepare acid. Concentrated acid is already there. So I want to prepare a dilute acid. So I'll add water to the required amount of concentration which I want. So I can prepare from a concentrated solution, I can prepare a dilute solution. So here, often in chemistry laboratory, a solution of a desired concentration, whatever concentration I want, I can prepare it by adding water. Of course, definitely by adding a distilled water. Is prepared by diluting a solution of a known higher concentration. The solution of the higher concentration is also known as stock solution. Now, stock solution means when an acid jar filled with acid, concentrated acid, comes to the laboratory, it is a stock solution. And to this stock solution, I can add water and prepare a desired concentration as I require it for the practicals. So we will be definitely doing these practicals based on this, and you'll try to do this. The next slide is here. There are some problems of molality. So here one problem we'll discuss, and then we'll try to summarize most of the things. Now here the density of the problem is the density of 3 molar solution of NaCl is 1.25 grams ml. Calculate molarity of the solution. Now the answer is molarity is equal to 3 molecules of L raised to -1. Now the mass of NaCl in 1 liter of solution is equal to 3 into 58.5. Now 58.5 is the mass of NaCl. That is, mass of NaCl in 1 liter solution is equal to, now since they are taking 3 molars, so that's why it is multiplied by, that is mass of NaCl multiplied by 3. That's why it is 58.5 multiplied by 3. That comes to 175.5 grams of NaCl, which is there in the solution. So density of 3 molar solution of NaCl is 1.25 grams ml. Calculate molarity of the solution. So the mass of 1 liter solution is equal to 1 liter means 1000 ml into 1.25 grams, that is 1250 grams of NaCl in 1 liter of solution. Since the density is 1.25 grams of NaCl. Now here, mass of the water in solution is 12.50, that is in 1 liter, that is minus 1.7 grams, 1.75.5 grams of NaCl. So when I subtract this, 1250 minus 175.5, I get 1074.5 grams of the mass of the solution of water. So mass of water in solution is 1074.5 grams in solution. Therefore, molality is equal to number of moles of the solute, that is 3 moles, upon mass of the solvent in kilograms, that is 1.0745 kilograms. So when I divide 3 by 1.0745 kilograms, I get 2.79 molarity. That is molality, that is unit of molarity is m, small m. So this is how I try to solve this problem on molality. So let us summarize what we have studied up till now with at a glance of the chapter. We will see what we have studied. So first of all, we have studied what are different branches of chemistry. Then we have studied the valency, how will you define valency. Then we have studied different terms, that is hydrocarbons, catenation and isomerism. Then we have studied valencies, how will you define valency. Then we have studied different important valencies, that is valencies of some important elements which we use most of the time, and what are they called as, depending upon the number of the valency 1, 2, 3, 4. Then we have seen the introduction to analytical chemistry. What do you do by analysis? Analysis is of two types, qualitative and quantitative. Qualitative analysis, which we are going to study here, and qualitative analysis and quantitative analysis. So qualitative analysis is concerned with the detection of the presence or absence of elements. So inorganic qualitative analysis we are going to study when we are going to do in practicals. But here we are going to study quantitative analysis, deals with determination of relative proportions of elements in compounds and of chemical compounds in mixture. Then we studied what do we mean by molecular formula. Molecular formula means actual number of elements or atoms present in a molecule. And empirical formula means the simplest ratio of atoms of a constituent elements of a problem. Then also we studied how we can find out empirical formula and molecular formula. So we have studied some important formulas. That is, empirical formula, mass is equal to sum of the atomic masses of all the elements. Also we have studied molecular formula is equal to R into empirical formula, where R is any number or integer. The value of R can be found out by molecular mass upon empirical formula mass. Then we have also known the relation of molecular mass equal to twice vapor density. So these are the important problems. Then we have studied problems. We have tried to solve the problems on empirical formula, molecular formula on the given data. We have studied this descriptive method, and we have also studied a tabular form method, which most of the students found it easier to understand, and that's why I've solved most of the problems on a tabular form. There is a continuation part of the first. So this was used, tabular form was used to find out the empirical formula of the given compound on the given data. And then on the given data, we further tried to solve the problem and finally found the answer of the given problem. Then we solved some more examples on this with regard to copper sulfate solution, also with Na2CO3, then CH4N2O. And then I had given you a homework chart, problem number 5, to find out the molecular formula of the given data. Then we studied this problem, we tried to solve the problems, Na2CO3. Then we studied the next technique, that is stoichiometry, I would say, or stoichiometry it is known as. And then there are different types of stoichiometry, mass-mass relationship, mass-volume, and volume-volume. Then there are the several steps involved in it. several steps involved in it. How the first important step is to write down the balance equation, chemical equation, then write down the number of the moles, and then you write down relative mass or volume should be. Then and finally we try to calculate the problem. These are the problems which we solved. We solved about 2, 3 problems on stoichiometry. And then today we started with concentration of the solutions. And we said there are different types of concentration of the solutions. So we studied concentration of the solutions. And in this we studied mass percentage, also known as mass is also a weight. So mass percentage or weight percentage. Then we studied with mole fraction. Then we studied with molarity. Then we studied with molality. So we studied problems on these topics and try to cover the whole chapter. So we have finished, we have done with Introduction to Analytical Chemistry. So please write down notes and try to write down notes and try to be little punctual with the notes and try to be little careful, start studying hard, and try to look into the textbook. And whatever I have studied, I have taught you in the class, try to write down in your notebook and try to make your own notes. I've already given you some notes on the PowerPoint presentation, and try to study regularly. Chemistry is just like mathematics. You need lot of practice, and the more you practice, the more perfect you are. So have a nice day, and I stop my class here. So thank you. Stay safe, stay at home, and keep studying. Have a good day.